Hey everyone, I've been working full time for Enzyme for the last 3 months now, and today I want to give you an update on what has happened since. Um, I think if you followed me on Mastodon or even LinkedIn, I think you got some updates in between, but I promised a larger development update, and that's coming with this video. So you will notice that a lot of the stuff that I've been working on is really foundation work, is backend stuff, architecture, all this stuff that we need to build the real product functionality that the user is going to use later to make that possible. And I think the last 3 months were really dedicated to that. And you should always build that first so you don't have to change everything after you're done with it. So I've been working mostly from my downtown office. Right now I'm in my home office, and I think we could dive right in. First big thing, and I think one that I probably spent most of the time on over the last 3 months, is the new multi-node and cluster model. What that means is being able to run multiple enzyme nodes in a cluster. The old version, the one that you can currently download and run, that single node, you can't run multiple enzyme nodes. You can, of course, you can go and run multiple enzyme nodes, but they don't know about each other, right? What that means is you can't scale it. If you need more processing power, you can't just run a second node because it's completely independent. And also, if you want to build anything highly available, so being able to lose a node, that's also not possible without a real cluster model. Now, the problem with a cluster model is that it makes things more complicated. Of course, you can always go and just run one node. That's still possible like it was before. But the moment you want to run two nodes, the decisions that I'm making here early on in the architecture, those will really define and dictate how complicated it will be to run an enzyme cluster. And so I hope you'll see, and I hope later on you'll experience that I try to take care that it's as absolutely easy as possible, and that it's as frustration-less as possible as well, because I think we as software developers can actually do a lot and put less burden on the user and let the software do more stuff out of the box. So what this new cluster model brings, scalability, it lets you run stuff in a highly available fashion. And also it allows us to add some more features. Like imagine you have multiple nodes running for Wi-Fi analysis. The moment you have three of them, we can do triangulation, all sorts of fun stuff that's possible suddenly with a new model like this. The way it works, and what was very important for me to keep it as simple as possible, is that these nodes are pretty dumb, which means they don't even know there's other nodes running. They could just assume that they are the only ones. And there's no specific master node. There's no specific leader node. There's no leader election. None of that stuff that makes running these nodes in a cluster usually pretty hard and pretty frustrating. This works because most of the kind of cluster logic is really in Postgres, the database that you're already using. There's no additional dependency coming for this. Because the Postgres people already figured out how to do this. And a lot of people already know how to run Postgres in that way. And I can rely on some functionality on Postgres that is critical for building a cluster. For example, atomic operations. I'm not going to re-implement that. That's crazy. I'm going to use the functionality that's already there, that's battle tested, and that's very well supported by Postgres. So by doing that and by building it in a way where no request has ever go to a specific node and where no task is ever done by a specific node or by a master or leader, you can spin up a node, you can shut down a node. You don't really have to worry about what that does to the cluster, except the scaling, of course. If you have 5 nodes and they're at the absolute maximum of what they can do, if you shut one down, you're probably going to end up with 4 that are overloaded. That's the only thing you got to think about. But everything else, you can add them, you can remove them, especially for very flexible kind of modern cloud-based setups. I think that's going to be very, very nice. Another new thing, TLS. TLS, you might know it as HTTPS. The S in HTTPS stands for secure, and that's in pretty much all modern versions. It's TLS. It's basically encryption of your HTTP connection for your browser, but also for anything that connects to the API of Enzyme. Absolutely critical. It makes sure that no one can kind of spy or snoop on the data that you are exchanging over HTTP. But it also verifies for you that you are connecting to the server you're connecting to. So man in the middle becomes really, really hard or something like that. I believe that TLS should be enabled and enforced on pretty much any HTTP connection. That doesn't matter if it's in the internet or in your local network. But I think that that is often, especially for applications that are running in your network, it's often not the case. And the computational overhead of TLS, I think is pretty negligible by now. I think the reason why it's not is that it can be a real pain to set up. And that's what I'm trying to solve here. Two things are happening. First of all, TLS is now required. It is secure by default. Nzyme will not spin up if it does not have TLS configured. You have to have TLS on everything that Nzyme does. To do that, though, it has to be absolutely easy to configure TLS. In fact, it should just happen. It should just happen. Why wouldn't the system just do it for you, right? Clearly, because somebody has to give you and issue you a certificate if you don't want to use a self-signed one. But when you spin up an Nzyme node for the first time and it doesn't have a certificate configured, it's going to generate a self-signed certificate, which you can use for as long as you want or until it expires and you regenerate it. But that will allow you to immediately use TLS from the very first interaction that you have with Nzyme. Okay, it's self-signed, so yeah, it's not as secure as if it was a official kind of certificate that has been signed by a root authority. But that's still better than not having any encryption at all, right? And you can decide if you want to keep it or if you want to upload your own certificate. Now, the own certificate, you don't have to put this somewhere as a file in the right format and then restart the server and hope it works and probably crashes with a weird error that you have to debug somehow. You actually upload that through the web interface. And you upload it. It gives you a very kind of quick guide on what the file should look like. You upload it. It will work with all of the common formats of certificates and keys and then kind of cross-convert that as it needs it internally. And it will show you what the certificate is. It will show you for whom it was issued, when it was issued, what the subject names is, all of that. And if you feel like that looks good, you can press install. It uploads it, it installs it, and it restarts the internal HTTP server, and then it just uses it. And that's it. You can alternatively load it from a file if you want to. That is, if you, for example, distribute these certificates through some sort of configuration management, not a problem. And you can also configure wildcard certificates where it will match a node name and then automatically give it a wildcard certificate that you uploaded. And all that happens entirely transparently. It's really just 2 clicks. It configures the server automatically, and you're good to go. And there's always going to be TLS for you. Another new thing, kind of related to TLS, in fact, is encryption at rest. Data at rest is, I want to lean out of the window a little and say it's the opposite of the stuff that you want to encrypt with TLS, I guess. Is basically the data that's not currently in transport. That's what TLS is for. It's the data that has been stored in the database. It's the data that has been stored on disk somewhere, okay? But you definitely want to make sure that that data is encrypted when it's in any way confidential and any way critical. So think about when in the future, maybe Nzyme is able to connect to a Active Directory. Okay. That password, those credentials, you don't want to have those somewhere in a file. You don't want to have them somewhere in a database. Now, unfortunately, you need to have them somewhere, right? Because the application needs to keep them. So what Nzyme does is it encrypts them. It uses a pair of PGP keys to encrypt those confidential keys, data, anything that is at rest and should not be able to be accessed by anyone, even if they have the access to it. So it runs PGP encryption on top of it, and it will just leave it there until the system needs it again. And then it will on demand kind of decrypt it. Now you'll probably, if you've thought about a system like this, you'll say, but hold on, if you have a cluster model where you have multiple nodes, they all need the same PGP key then, right? Yes, they do. And they automatically transfer them between the nodes. So let's say you start with your first enzyme node, that will automatically create a PGP key pair for you, keeps that, and uses that to encrypt stuff. Now you spin up a second enzyme node. That one, when it spins up, will notice that, number one, I don't have a PGP key. Number two, I'm joining an existing cluster. So I'm not going to create my own new PGP key. I'm going to request the cluster key. And then the other node is going to answer to that and send it over. That happens through Postgres, so there never has to be direct communication between the two nodes. And you can disable that if you want. If you're in a super high kind of security environment, you don't want that to happen automatically. It's all authenticated, all encrypted. So don't worry that anyone can just come and say, hey, give me the PGP key. That's all thought through. But you can disable it if you want to. But if you keep it on, which I guess for most deployments is going to be absolutely fine, it will be distributed automatically between the nodes. You can regenerate those keys. So let's say you want to create a new key pair, then it's going to even re-encrypt the data that has been encrypted with the old keys to work with the new keys. And that way the data is really secure. The data is not ever unencrypted anywhere, and Nzyme takes care that when it ever handles any sort of confidential data or critical data, that's always encrypted at rest. And now you probably noticed that there's a bunch of new stuff already in Nzyme, right? And I think by definition that adds some complexity to it, some things that you have to think through. And I think a mistake that a lot of software developers make I think not from bad intent, but from being in the wrong environment or circumstances, is that they say, oh, well, that's not my responsibility, right? So let's say, for example, with this new cluster model, just like with any other cluster model out there in the world, it is absolutely critical that the timestamps or the local time on the servers that are running in the cluster are synchronized. Okay, they have to be all within a few milliseconds, maybe a few seconds of the same time. If one is multiple minutes off, that kind of creates all kinds of chaos in your cluster because communication suddenly stops to make sense. And I think what I've seen in the past is they now say like, well, that's not my responsibility. You're the administrator. You got to make sure the time is set up right. And I can follow that thought. The problem is for the user, and that's who we create the software for. In the end, it's still their problem. And in the end, it's this problem in your software that this triggers. And in the worst case, this is not just triggering a complete failure of something, but these frustrating little things that are starting to go wrong. So, for example, let's say the local time is off and you're searching for something and it doesn't find it because it thinks it's a different time. So you search backwards in the last 5 minutes over some data, and because it doesn't even know or it's wrong about where 5 minutes ago starts, it gives you data that's just not what you expected. And you have to, in this case, probably reach out to support. You have to Google, because there could be 10 other reasons why it doesn't find it, right? And so we're not going to say, hey, this is 100% your responsibility. Of course, in the end, you got to configure it. We're not going to go in and configure your local time, but we can warn you. We can check for these common failure scenarios and we can warn you about it. And that's what the health console is about. It's in the web interface and it's basically a bunch of green, red, or yellow lights. And they show you if everything's green, that means everything that we're checking for is good. Don't worry. If it's yellow or red, that means something is not working the way it should be working. So my timestamp example, for example, would be that the node clock indicator would light up. It would show as red. It would send you an email, it would trigger an alert and say, there's an issue with the node clock out here. And on the health console page, it's going to show you a box that says, hey man, something wrong with the node time. Here's what that means. Here's what an acceptable range is. In this case, it has to be within 5 seconds of the actual world time. And here are the consequences of this, which is you're going to run into all sorts of cluster synchronization issues. Reports might be sent out delayed. Alerts are going to be all over the place. It's a disaster. You got to fix this. This is one of the things that we're relying on, okay? And then on the right side, it's going to show you the steps to actually identify which node is affected by this or which nodes. And then for each affected node, it tells you, hey, please install NTP on it. Okay, that's just got to do that. And then the indicator will no longer illuminate after about a minute or so when the next check runs, and it will see, okay, yeah, time's good now, no worries. There are, I believe, 12, 14, 16 or so, I think, indicators already that check for all sorts of scenarios. Another one is if your TLS certificate is about to expire. That's frustrating, right? And again, we could say, hey, you should have a service that checks for your expiration period on your TLS certificates. But yeah, you should, and I have that. But maybe someone forgot to configure it. Maybe you just don't. Okay, why not spend the extra time to build this into Nzyme to avoid this frustration? Because it's not necessarily that you are the one who notices that, right? You could say, well, my browser's going to tell me, and then I install a new one. No, I think what's going to happen first is that your tabs, the things that are collecting the data and are collecting them and sending them back to Nzyme, they're not going to accept an expired certificate. So suddenly there's no more data being collected. And so now you're wondering, is it tab down? You got to log in, you got to look at it. What's the error? Ugh. So why not show you that first and help you? Actually, everything's going to show you 7 days early. So you have all the time in the world to install a new certificate. Like I said, there's 12, 14, 16 or so. I would have to count them indicators already. And for every new feature that comes, there's actually a step in the development process where we say, hey, is there any indicators we need to write for that? Like for the PGP distribution, for example, there's one that says, hey, your PGP keys are out of sync. That's going to be a disaster too, because now you're going to encrypt with different keys. And there's all sorts of mechanisms to avoid that to happen. But if it still happens somehow, Nzyme's going to alert you about it. And that's one of these things that we put in there to avoid frustration and kind of go a little bit over the boundaries of what Nzyme is really responsible for and help you alert on that, help you avoid problems, even if we could say, yeah, it's not our problem, that's the user's problem. Because we don't want the user to have problems, right? And you can disable them. You can say, you know what, don't worry about this. That's your choice. But we think that's going to lead to a very smooth process of running Nzyme. So what's coming next? This was the first 3 months of working on this full time. And if I think about where are we going to be in another 3 months, I'm thinking about, man, we're going to be in the middle of the summer, right? It's going to be July. We're going to be halfway through the year. First of all, I hope, or I think, because this is really my responsibility, there's going to be more of these updates, and they're not going to be just every quarter. And then second, if you want to stay kind of up to date in between, follow me or Nzyme on LinkedIn. Follow me or Nzyme on Mastodon. That's where you can get kind of these real-time updates and some previews of stuff that's coming. Okay, that's what I would recommend. But now what is coming next, right? What am I going to work on next? The next big topic, and I think that's the last big kind of back-end, not super exciting for the actual use case of Nzyme work, is going to be a new authentication authorization model. The previous version of Nzyme, it was one admin user with one password, and that was it, right? That was honestly because I didn't have the time to build more into it, and the previous Nzyme version was really a little bit of a prototype, right? Pretty clearly not enough for what's coming. So it's coming with a fully multi-tenant model. And I know everyone understands something else when I say multi-tenant. If you talk to an analyst, that's something else, and someone runs in the cloud, then an MSSP, then an MSP, then you're just running it internally, right? So I hope it's the multi-tenancy to the full extent. That's at least what I've planned so far. The planning for that has advanced pretty much. And I think over the next 2 or 3 days, the coding on that's going to start. There is a GitHub ticket in this also. If you go into our GitHub, you can search for authorization, authentication. You're going to find that ticket that explains in all detail. There's going to be super admins, org admins, tenant admins, tab admins, whole good stuff, and a very flexible kind of individual permission model as well. That, of course, that needs a bunch of time to build because there's a lot of front end, there's a lot of testing, there's a lot of security work around this because this obviously has to work really, really well, right? But I think there's going to be a bunch of updates coming in between. And I think that's something we're going to look at in the next development update once that is ready. The other stuff that's coming is right after that. I'll be working on the full re-implementation of all Wi-Fi functionality. That's all moving out of the Java code, going into Rust code. So truly a full re-implementation. Plus maybe a few new things. Now that we have the multi-node model, now that I've learned a lot about how people use this in the end, a lot of new stuff also coming. And then also the first, I would say, parts of some Ethernet protocols as well. I have a pretty good support of DNS so far, but of course there's much, much, much more out there. So I think we'll be able to look at the first analysis, the first threat detection, the first asset inventory, all that good stuff in the next development update as well. So stay tuned. I promise you there's more exciting stuff coming than TLS and cluster models and all of that, but I still wanted to give you an update on where it is. And like I said, follow me or Nzyme, Mastodon, or LinkedIn. And then also definitely subscribe to this YouTube because I think I'm going to upload a few kind of shorter videos and kind of shorter updates on here as well. And I hope you enjoy it. Leave a comment and just reach out if you have any sort of questions. There's the Discord and then all the other social media platforms that are out there. So thank you and stay tuned.